Hey everybody, welcome to the Ignited Podcast, Striking Industrial Automation Conversations. We're your hosts. I'm Travis Cox.
And I am Thomas Burke.
And we have a great episode for you today. This is titled From Cables to Context, How AI and a Smarter OT Stack Are Rewriting Industrial Digital Transformation.
Today, we are joined by someone who has become one of the most influential and recognizable voices in our industry, Jeff Winter. Jeff is a leading authority in smart manufacturing and Industry 4.0. And if you spend any time on LinkedIn or around digital transformation conversations, you've definitely come across his insights. Jeff is the Vice President for Commercial Strategy for Belden. Jeff brings a deep background really in industrial automation, digital strategy, and manufacturing operations. And he's played a major role in shaping where the industry is headed. He serves on the board of directors for both MESA and for ISA, the International Society of Automation, two organizations driving some of the most important standards, innovation, and workforce development in our space. We're excited to have him on the show today to talk about what he's seeing across the industry, where smart manufacturing is going next, and how organizations can truly prepare for the future for someone who's been truly the center of it all. Thanks for coming on the show, Jeff.
Thanks for having me. I'm excited to be here.
So, Jeff, you're in front of a lot of manufacturers, industrial leaders constantly. Where does AI adoption in OT actually stand today? And where's the gap between the hype and what's really happening on the plant floor?
So I love this question because it shows how widespread and broad a concept like AI actually is. It's one of the very few technologies that is completely ubiquitous in its application and its reach. It touches every role, in every function, in every department, in every company, everywhere. So because of that, AI adoption is actually really hard to pinpoint. You will get widely different answers from different studies. And trust me, I've read probably most of them. And a big reason is that AI is still an abstract concept that we do not all define the same way. So let's just use this one topic, just OT and AI's adoption in OT. Is it the same old OT systems? There's suddenly AI because we added a ChatGPT style interface on top of it, or a co-pilot just for reporting metrics from an OT system? Or what about a better user interface? Or what about a PLC code assistant? Is that adoption within OT, or any sort of just engineering productivity tool that touches OT? So it becomes really difficult to answer. On top of it, almost every single industrial software out there right now has some sort of machine learning at a minimum embedded into it, whether it's for analytics or prediction or optimization, anomaly detection. And the line gets really blurry when you start to do large language models or any agentic side. And there's many levels of agency and many levels of intelligence. So when someone asks, where does AI adoption OT stand? My answer would be this: farther along than the skeptics think, but nowhere near as mature as the headlines imply. But if you define it broadly, adoption looks huge. There was a recent IoT analytics study that came out a month or so ago that reported 96% of machine builders are actually in some stage of AI adoption. But the details matter because that includes companies, scaling specific use cases as well as those still running targeted pilots. Their same summary in that same report actually notes that the top barriers include everything from like cost to data infrastructure, skills gaps, which tells you the adoption is real, but not frictionless. It's running into, some problems. But if you look at the plant floor, then it completely switches because now it typically applies to use cases. And some of them are just the most basic, things like quality inspection, predictive maintenance, anomaly detection, production optimization, even troubleshooting support or operator assistance. IoT Analytics actually had a different study in 2025 just dedicated to industrial AI, and they found that automated optical inspection was the leading industrial AI use case amongst 48 use cases that were analyzed, and it was only at about 11%. while Gen AI-based industrial use cases were still under 5% of the time of their analysis. Now, this was in percentage of total spend. If you actually look at the highest adoption, it was production optimization. So what that tells you is more people are applying it to production optimization. Those that do spend it on quality end up spending more. And now this creates, obviously, a gap between hype and reality, like you said. I mean, the hype is everything autonomous factories, AI agents running production, and there's some magical brain that fixes decades of messy processes. But the reality is nowhere close to that. It's much more practical. Manufacturers are applying AI where the problem is measurable, where data is available, where the risk is manageable, and the value is hopefully easier to prove. And that is why quality ends up becoming such a good starting point, because you can measure defects, you can measure scrap, you can measure rework, you can measure false positives, inspection time, customer escapes. Just the cost of poor quality is easy to calculate. Predictive maintenance is kind of like a similar one, a close second. It's because you can look at, an asset's critical enough and the failure modes are understood. So it becomes very difficult to answer this, because then you have things like co-pilots and engineering assistants that can be very difficult to trace to a specific problem that they're solving without requiring a huge amount of effort just to prove its worth. So I would describe, like I said, AI in OT today as use case rich, but operating model immature. And there's a whole bunch of examples that show that companies are not quite ready for applying it the way that we see in the headlines. And the biggest issue isn't curiosity, because the curiosity is there. The gap is more readiness. Many manufacturers want AI outcomes, but they still have fragmented data. They have inconsistent processes, disconnected systems, and more importantly, probably unclear ownership and a workforce that's not prepared for all the changes necessary to take advantage of them. So the companies making the most progress are not asking, how do we add AI? They're asking, where are we slow? Where are we reactive? Where are we blind? Where are we inconsistent or too dependent on our people to do stuff? Those are the ones that are adopting AI and really making it work.
That's intense. And I get that. And I really am a strong proponent and believer in that. My background has been data acquisition. My background is OPC and things like MQTT and Sparkplug. And, I think a lot about all these disparate devices and disparate networks out there and the mountains of data that people have with all these different manufacturing companies. And they're sitting on all this data. They don't know what to do with the data. So what do you think the missing sauce is, or the missing ingredient? And how does data contextualization change that with all the data that's out there?
Well, I think the answer is easy, but what it implies is difficult. The missing ingredient is not more data. We already have way more data than we know what to do with. The real missing ingredient is meaning. But what does that actually impact? Well, a lot of manufacturers have, like I said, the specific OT data that they actually want to use for specific use cases, but the data is trapped at the level of signals. This could be like temperature, vibration, speed, pressure, runtime, alarms, and faults. Are those useful? Absolutely. Are they actionable? Not by themselves. A number does not tell you whether it matters or not. It does not tell you what asset it came from on its own, or what product was running at the time, or what order was being made that it was attached to, or what conditions were normal and what changed, and who owns the response, or what business consequences are attached to it down the line. That is what data contextualization does. It turns that signal into a situation. A vibration reading becomes more valuable when you know it's on a critical asset during a high priority production run, tied to a known failure mode with a maintenance window that's coming up tomorrow and a customer order that's at big risk for the company. Now it's not just data, it's prep for a decision that you can make. So the profound part is what I think is that manufacturers do not have a data problem as much as they have an interpretation problem. That's like the real crux of this. They can see more than ever, but they can't always understand what they're seeing fast enough to act. And so when you have that, you end up realizing that your decisions that you're making today are actually harder They're taking longer because you have more visibility into more data and you don't know what to do with it.
Yeah.
And so if you can contextualize it, it shortens that gap. And I like to refer to it as decision latency, the amount of time it takes you to notice, interpret, agree, and act. And that's what data contextualization allows that to be shortened.
Yeah, and if you look at the systems that we've had, historically, if we're going to build a SCADA system, what we're going to do? We're going to connect that SCADA system to all the information that it needs, right, to bring that in so that those operators can run that system more effectively. Same thing we do with the MES systems and others. And I think what you're really alluding to is that we got to think about data completely differently now, right? Data is important across the entire enterprise to all of these different systems that are out there, and they got to be connected together. And I think that's a lot of exciting stuff that's happening right now in terms of being able to, figure out what our digital infrastructure needs to look like, for a customer. How do we get data in there? How do we contextualize? How do we add the knowledge and the meaning to that? So the relationship, so that we can go that next level, right? There is a plethora of data. We've been able to get it out of these islands, but that next level is the organization's got to figure out how to provide that meaning so that it can be useful for these AI systems.
So maybe it shouldn't be a digital transformation. It's an information transition that you really want to do, because we want information. We don't want just raw data anymore. We want information that's useful.
And this is something that, is very near and dear to our hearts, inductive automation. With Ignition, we really want to put the best platform out there to help with these kind of problems. But how are you seeing platforms like Ignition that are, coming into these facilities and into the modern OT stack, pulling data together, contextualizing it, kind of bridging the OT and IT, and even to the cloud? How do you see, that role in AI-ready infrastructure strategies, in bringing the right platforms in?
I think the big point is that AI-ready infrastructure does not start with the AI model. It starts with the data environment that the model is expected to learn from, to reason against or reason over, and eventually act upon. And in manufacturing, that environment is notoriously messy. That's part of the whole reason why we're talking about this. The most important data is often sitting inside of PLCs, machines, historians, SCADA systems, databases. Hopefully not, but spreadsheets, it could be just system logs, quality systems, and worst, tribal knowledge. So the question becomes, how do you turn all of that into something usable without ripping everything out and starting over? And this is where platforms like Ignition become really important, not because they are an AI platform in the flashy sense, but because they can sit close to the operation, connect to a lot of different systems, organize data in a way that can be understood, and then make that data available to the rest of the business. That bridging role matters a lot. And because AI does not just need data, it needs the context. A tag value by itself is not enough. The system needs to understand the asset, the line, the product, the batch, the state of the process, what normal looks like, things that have changed, and then ultimately what business outcome it's connected to. Without that, your AI is just analyzing stuff that isn't really important because you don't know what it's analyzing for what reason. So I see platforms like Ignition as a part of the connective layer in an AI-ready architecture. I mean, it helps manufacturers move from the raw operational signals to the contextualized operational knowledge that's necessary. And once you have it, AI becomes much more practical. You can start building use cases around these functional things like downtime, quality, maintenance, energy, reporting, scheduling, even operator support, because the data has enough structure and meaning to support the decisions that those teams make. But I think the big mistake is thinking that AI readiness means send everything to the cloud and figure it out later. AI readiness means the organization knows what data matters, where it comes from, what it means, who trusts it, how it moves, and how it gets used. And you have to kind of have all of that. And platforms that help create that bridge between OT actual reality that's happening and the enterprise intelligence capabilities are going to be central to kind of what comes next.
Yeah, I love that you're calling that out, because we definitely still live in a legacy world, right? We're not replacing all the equipment that's out there. We need to be able to get that data, get meaning to that data, along with being able to put new stuff in at the same time to make that all accessible to these new tools that can really transform the business.
Jeff, and you used the word trust in your last statement. And, right now, the multitude of AI tools that are out there is just overwhelming. We don't even have an idea how many there are, but a lot of the companies are scared to death from a security perspective. Is AI going to, make things troublesome? And are we going to be subject to attack of our data? So, how should the manufacturers kind of think about balancing productivity gains and the use of AI tools with the corresponding security risks that people are thinking that come out together, if you're thinking about connecting up to the plant floor? We've got all this data, we still want it secure. Is AI going to exploit things and make things insecure? And how do they deal with that?
Well, to start, I would not frame this as an AI productivity versus security mindset, because in OT, and honestly everywhere, these are not separate conversations. If the plant cannot run safely, reliably, and recoverably, then you did not create productivity. You created dependency and risk. And so the reason that this matters now is that AI changes the attack surface in different ways than traditional digitization and just connectivity did. It's not just another system on the network. It introduces new data flows, new identities, new integrations, new cloud connections, new vendor dependencies as part of it. And that just creates a whole bunch of different risks that we're not necessarily used to. And the software can now influence decisions to the physical processes. And that's why NIST's generative AI guidance is pretty direct on this. AI can expand the attack surface through things like prompt injection, data poisoning, and the use of AI to lower the barrier for just offensive cyber activity. And this is happening in an environment that is already under pressure. Dragos reported in 2025 that it tracked 119 ransomware groups that were focusing on hitting organizations. And it was up from 80 just the year before. And this impacted thousands. It was something like 3,000 organizations. And manufacturing took up 2/3 of the victims. And another company, Clarity, also found that more than 12% of industrial organizations in 2025, they had OT assets communicating with malicious domains, which is a pretty clear sign that the exposure is very real and not just theoretical. So the answer is not slow down AI. The answer is stop treating AI like a feature and start treating it like a new operating capability that needs governance, it needs architecture, and it needs controls. So I would like to say it is the closer AI gets to the physical processes, the higher the standard needs to be. A co-pilot that summarizes production reports on one level of risk, and the model recommending a maintenance action is a totally different one. A system that can influence set points, robot motion or production sequencing, that's a safety critical, totally different category. And that means that manufacturers need to ask very practical questions. What can the AI actually see? What can it change? Where did the data actually go? Who approves the recommendation, and can a human override it? Is the action even logged? Can we even explain what's happening? And a lot of these questions you need to have answers to. And luckily, there's standards out there trying to help people. I think it was just in December of 2025, CISA and NSA and a few different international partners, they released guidance specifically for integrating AI into OT. And it's kind of centered around understanding AI and evaluating how it's used in OT. And they help give you frameworks for establishing governance and assurance and embedding safety and security into AI-enabled OT operations. So I treat it as don't let AI become your intern with plant access.
Right.
Are they helpful? Sure. Are they powerful? Maybe. But it should be able to. You should not let the intern touch everything on day one. Absolutely not. You need to put guardrails around that intern, and you need to put guardrails around your AI.
Absolutely. I mean, it's got to be an inherent, security and, the governance around AI. It's got to be an inherent part of the organization. And you have to have, leaders that are driving that. And especially having OT and IT coming together, doing that in the right way. They can't be operating independently with, in order to really mitigate the risk the most way. Now, there's not just anxiety around the security aspects of AI, but there's anxiety around AI and automation on the plant floor itself. What does it mean, Jeff, for the operators and technicians who built their careers around these systems? Is the industry handling that conversation well in terms of, is AI going to replace me?
It's going to replace everybody. Everybody told me that. It replaced you and I. We're going to be AI generated next week.
I think the anxiety is real. I mean, we should not dismiss it with some corporate slogan or what I picture like a poster. It just says, AI will empower the workforce. I mean, that may be true, but it's not helpful if you're the person wondering whether the skill you spent the last 20 years building is about to be turned into the next software feature of an update that you guys have. I really think the honest answer is that AI and automation, they're going to change work. I mean, some tasks will flat out go away. Some tasks will get easier. Some decisions will move faster. Some knowledge that used to live only in the head of a great technician may become accessible to everyone. And that is powerful, but it can also have people feel threatened if, we're just going to pretend everything is an upskilling opportunity and move on. So the way I like to think about it is more like this. The best operators and technicians have never just been button pushers or wrench turners. They're people that understand the sounds, the smells, the timing, the workarounds and failure modes of all things that are happening with the machine behavior. They know all the weird little realities that never make it into a manual. And AI may be able to process more data, but it does not automatically understand the plant. It needs the people who actually know the work. So the opportunity is not to replace that expertise. The opportunity is to capture it, to scale it, and to give those people better tools. I mean, now imagine a technician who can troubleshoot faster because the system is surfacing up like the 3 most likely causes, or an operator who can better give guidance during a changeover, or it could even just be a new employee who can learn from all the knowledge of the best people in the plant instead of waiting 10 years to absorb it by osmosis or only when things go wrong. But is the industry handling that conversation well? I don't really think so. I mean, we talk too much about the technology and not enough about the identity shift. I mean, for a lot of people, work is not a task list. It isn't for me. I mean, it's pride. It's a competence, and it can be a status for every person everywhere.
Yeah.
Right.
It is, I know this machine better than anyone. And if AI, if it kind of is treated like this mysterious black box that's coming down from corporate, the people are going to resist it. And honestly, they probably should. The companies that get this right will bring operators and technicians into the design of the feature, not just the rollout of the software. They'll ask, where does this help? Where could this hurt us? What do you know that the system does not? And what should actually never be automated, and why? And what decisions still need to have that human judgment? So do not automate the work and alienate the worker at the same time. That doesn't help the company, and it definitely doesn't help the individual. If the people closest to the process feel like AI is being done to them, they're going to resist it. If they feel like AI is built with them, they can make it better than any vendor demo ever could.
It kind of harkens back a little bit to OE and manufacturing a little bit, and that a lot of people were kind of really fearful of that coming in, right? As being the big brother, or we're being watched, and we're going to get in trouble if we don't have our productivity up. But the companies that were really successful in driving that performance and is the ones that engage with the operators and to help really understand how we can improve process. And it's not about judging people. It's about learning from their experiences to make this thing better. And now we're in an age, I think, with AI where we can go a lot further with that.
Right. And, we keep seeing all these technical innovations. Where I live in Arizona, they got the driverless cars, the Waymo. Who would have ever thought we'd have that where, I don't have a driver anymore. It's all AI. The whole thing is being monitored and drives the car for you. That's really cool. It's scary to people. I know people that are scared to death to get in a Waymo, but it's technology that's here today. So, Jeff, you are the vice president of commercial strategy for Belden. And in that role, where Belden started as what I always thought of them as nothing but a cable company, right? That's what you guys did. You built cables, you built connectors, right? But now it's really evolved into what I call a digital transformation, infrastructure powerhouse. Walk us through that journey of where Belden has gone from cables to a digital transformation and the infrastructure. And what did it take to make that shift from the cable company to the company it is today?
Well, I love this question, and part of it is why I'm in the role that I'm in and why I work for Belden. I actually do think it's a pretty incredible story, and we're in the middle of it. It's not a complete story. The story is not done. But if you look back, Belden has been around for over 120 years. We started in Chicago in 1902, and yes, we made wire and cable during an era where electricity was brand new. And for many decades, we were known as the absolute gold standard in kind of that physical layer of wire and cable. But fast forward to the last couple of decades, and the strategic driver for our shift was really simple. The world changed, and we listened to our customers, and we entered this era of Industry 4.0 and digital transformation. Our customers didn't just want to buy a spool of cable or a connector anymore. They were dealing with massive new complexities, everything from IT/OT convergence, the explosion of data, especially more recently at the edge, and serious cybersecurity threats that are happening. And so the value shifted from just the physical wire to the entire network architecture. They needed guaranteed uptime, secure data flow, and actionable insights. So to make that shift from a cable company to a digital infrastructure powerhouse, we had to fundamentally change our DNA. And I think it's occurring, not occurred, but occurring because of three things that are happening. First, highly targeted acquisitions. I mean, we went out and acquired heavy hitters in industrial networking and edge computing and cybersecurity. Brands like Hirschman and Lumberg and Macma. We didn't want to just connect the network. We wanted to route it and manage it and secure it all together. Second, we had a totally new go-to-market approach. I mean, we had to stop selling individual parts and we have to start engineering full solutions. So we built customer innovation centers all over the world where we actually bring customers in, we roll up our sleeves, and we co-create and test these complex architectures before they ever even hit the factory floor. And third, I would say, is a massive cultural shift. I mean, we had to break down internal silos, and we had to, integrate all these different technologies to operate as one Belden. I mean, we just recently did a company reorg to support this. And so today, Belden sits at a really interesting intersection. You have your physical infrastructure now meets your digital intelligence. And so we're not just connecting devices, but we're helping customers capture more and act on operational data in real time. And where are we headed? I'd have to say the next frontier is about making that even more turnkey. So think AI-driven network management or deeper cybersecurity embedded into the infrastructure itself, and platforms like Belden Horizon that let customers operate their network without needing an army of specialists to do it. So the vision is becoming the trusted partner that makes complex industrial and critical infrastructure just simply work. From the cables in the wall to the insights on the screen. And I'm honored to be a part of that journey and helping to shape it.
And we're really excited to have, to be partner with Belden and as part of our technology ecosystem program. A lot of people are looking at like, well, yeah, why is Belden? Well, because, right, what you just said there, Jeff, right? You've transitioned in. And there's a lot of organizations who need that infrastructure, right? In order to really build all the stuff we were talking about, we need to have the fundamentals in place. And there's a lot of legacy out there, right? There's a lot of things that are connected today. And so the work that you guys are doing is incredibly important so that platforms like Ignition and others can really come in and help lay that foundation in the right way. So, we have to kind of ask the famous question at the end. You're a big part of all this. You're right in part of this movement. What are you most excited about here as you look forward around AI, around what you're doing, and where you see this industry is going?
You'd think because I participate in so many conferences all over the world, I'm on the board of advisors for almost a dozen companies, that I would have the perfect answer for this. But I think if anything, it exposes me to more curiosity and more realization that I don't think anyone knows. And if they're going to attempt to predict it, they're guessing with confidence, because it is really hard to predict the future right now, because technology is moving so fast that every 6 months the 5-year vision gets completely rewritten. And yes, we've all seen Terminator 2, so let's not pretend, the answer is, well, let's just connect everything together and let the AI or the robots figure it out. I actually think most manufacturing will change slower than hype suggests. We will still make physical things. We will, with physical materials in physical plants under physical constraints. And a lot of companies will add practical bolt-on tools, better reporting, better troubleshooting, better maintenance, better quality checks. Useful, but not revolutionary. I think the bigger story is actually going to come from separation. Some manufacturers will use technology to completely rethink how they create and capture value. They will connect engineering to operations, to supply chain, to service, and even with their customers in ways that let them learn faster, respond faster, and operate with just ease. And others, will just put new software on top of old ways of working. So like 5 years out, I think we're going to start to see a lot of co-pilots and incremental gains. 10 years out, I think we're going to see a much wider gap between manufacturers that are truly great at manufacturing and companies that probably should not be manufacturing everything themselves. And that's where I actually think contract manufacturing might grow. Some companies will focus on their brand, their product, their design, their R&D, while specialized manufacturers are going to quietly become the best in the world at actually just making things. So the future, is not the factory becoming a spaceship. The future is a few companies get so good at manufacturing that everyone else starts to look very expensive, very slow, and very optional. So that's kind of where I think it's going in terms of what I'm most excited about. I'm honestly really excited to see kind of where AI settles in the impact that really gets adopted. It's so capable and so powerful in so many ways that I want to see where the dust kind of settles on the areas that everyone completely agrees. Absolutely, that's a no-brainer. Everyone needs to do that just to kind of stay afloat, let alone be an advantage.
Totally. And now I guess we know why, if you looked on Jeff's LinkedIn page, why there's a nod to Terminator on there, right? I love that graphic, by the way. It's awesome.
And that was made before AI.
Oh, awesome.
Jeff, I want to thank you for taking time out from your day today, and thank you for sharing all your expertise. I got to say, as Travis and I have been talking, this is a very exciting time for an engineer and for suppliers and system integrators, with everything going on with the convergence of our technology and the maturity of OT and AI. So, I guess the thing is, I encourage everyone to connect up with Jeff. His contact information is here on LinkedIn, and stay connected with, everything going on with security and AI for your information transformation. The technology is here to stay. Stay on top of it and be part of it.
And as always, everybody, please stay connected to Ignited. Subscribe on YouTube, Spotify, and Apple Podcasts so you never miss an episode. And thanks again so much, and we'll see you next time.